Thank you very much. Yes, thank you. Thank you.
Assalamu alaikum, everyone, and good afternoon. My name is Dr. Bashriya. I'm an associate professor in the Sustainable and Renewable Energy University of Sharjah. Actually, I have been, it's pleasure and honored to be with you today, inshallah, in the technical session. In this section, inshallah, we're going to hear from we have going to hear and discuss different scientific papers written by or presented by pioneers, women in research. So our first session will be presented by Dr. Suzanne Peterson. Prof. Suzanne or Dr. Suzanne, she succeeded to gain different titles. She's an associate professor in the dentistry. She's an associate professor in the School of Medicine and Dentistry at Griffith University, Queensland, Australia. She is the director of water health. She is non-executive director of Sydney Water Corporation. She is an editor of Journal of Water and Health. Dr. Suzanne worked internationally on the development and implementation of quantitative microbial risk assessment for water safety management in the drinking water, recreational water, and sanitation context. Her expertise lies in the integration of human health-related microbiology with modeling on environmental system. Now, with Dr. Suzanne and the session entitled Safe Water, a risk-based approach for protections from waterborne diseases. Dr. Suzanne, the floor is yours. You have 20 minutes for presentation, then 5 minutes for questions and answers. Welcome, Dr. Suzanne.
Thank you very much for your very kind invitation, and it's a real privilege and honor to be with you at this important meeting. I will share my screen with you. So I'd like to share with you today about a risk-based approach to ensuring water safety, and to give you a bit of an introduction into some of the science behind it if you're not familiar with this, and to point to some of the research questions that are still yet to be answered, and some of the really interesting things that are still being worked on and where we're heading towards in providing safe water in the years to come. So if I was to ask you, how do you know that your water is safe to drink? If it was just as easy as looking at the color in the glass, then it wouldn't be such a challenge, would it? But there's all kinds of things that can make water not safe for us. We can classify them into pathogens, infectious agents, chemicals, radioactive compounds. My particular interest is in the pathogens. And there are a lot of different infectious agents that are transmitted by water and by waterborne routes, hundreds, thousands, so many that I'm sure we still haven't even heard of. But we tend to classify them for the sake of management and understanding them as bacteria, viruses, and protozoa. So these are different groups of organisms that have similar characteristics. Bacteria can grow in the right conditions. They tend to be quite susceptible to disinfection. Viruses are much smaller. They tend to be there in very high numbers. And the protozoa are more complex, they're larger, and they can form really resistant cysts in the environment. And for example, Cryptosporidium is very difficult to inactivate by chlorine or disinfection, and so we need to look at other ways to remove it. So we use these common characteristics to help us to understand how to protect human health. All of the organisms I'm talking about today lead to gastroenteritis predominantly, and while in developed countries, gastroenteritis is often considered to be, you know, a self-limiting disease. In many parts of the world, it still can lead to very severe health outcomes. And even in, you know, in where there's the best healthcare, there are sequelae and consequences of these infections that can stay with people for the rest of their lives. So how do we assess whether water is safe to drink? Well, in the traditional approach was to take a sample of the finished water, whether it's from the tap or at the out of the end of the drinking water treatment plant, or even from the water source, and to test it to see if it had indicator organisms in it. Now, indicator organisms are not pathogens, but they tell us something about whether there's fecal contamination in the water. But we've always known that it's a very poor indicator of whether that sample is safe. Because it's only a small amount that's tested, it takes time to get the sample back. Typically, by the time you find out that the water is contaminated, it's been distributed and drunk or exposed by a lot of people. So we've always known that this is not really a very adequate means. The other thing that we look at is we look to see if people are ill or becoming ill. But when it comes to something like gastroenteritis, it's very difficult to really track how many people are unwell, because in order for that to be registered by authorities, it needs, I've got a picture here of the notification pyramid. People need to be exposed, they need to become ill, they need to be unwell enough to visit their doctor. The doctor needs to be concerned enough to take a specimen, send it to the lab. The lab has a positive result and they can identify and notify. So actually a very small proportion of those who become ill with these gastrointestinal pathogens will be identified. And then there's a whole range of pathways. They could have become ill from person-to-person exposure, perhaps with their children, perhaps with a friend, or through food, any number of pathways. So identifying it, that it's an issue from drinking water, is extremely challenging. So in response to this, around 2000, our approach to assessing whether water is safe and to knowing that it's safe took a shift. And so rather than looking at just the finished product or thinking about whether people are unwell, we started to look at risk assessment, which is, in order to know whether that water is safe to drink, we need to know something about its history. Where has it come from? What are the sources of contamination to that water? And I think this is a really nice diagram that shows just schematically that in any waterway or surface water source, there's a whole range of different sources of contamination. It could be people up in wilderness areas. It could be livestock, and some pathogens, the bacteria and the protozoa from livestock can infect humans. It can be land application of biosolids, for example. It can be chemical applications that could then end up in the water. And all of this complex mix of contaminants contributes to what is in that water when it is taken to the household. So understanding how contaminated that water is and what's required in order to achieve safety is how we approach it now. And to put this together more formally, and this is the way I have my slides set up today, is to think source. Where does the water come from? What are the controls? How has it been treated? And how sure am I that those controls are working? Exposure. How much water has somebody been exposed to? How much unheated water have they drunk? Or how much have they used, for example, if it's to wash their clothes or to flush their toilet or any number of other purposes, what's their exposure? And then the health impacts. Given that exposure, what's the likely health outcome? So using this approach, we can then assess the risk and compare it to a target to say, is it safe or not safe? And controlling each of these factors then becomes more effective in ensuring that it's consistently safe for the consumer. So the framework for safe drinking water, and this was the first framework that was applied and used in the WHO guidelines is one, to define a health-based target. So that's what am I aiming for safety? And then 2 is to develop a water safety plan. So what is my approach? What's my strategy to achieve that target? And then thirdly, looking at the surveillance, checking to see through what's happening in disease in the community that we're achieving that outcome. So some nice photos now to give you a feel for where I'm from in New South Wales in Australia. A diverse range of different water sources. This is from a wilderness area down in the Snowy Mountains. A more populated agricultural area also in the highlands. A beautiful north coast waterway that has a lot of agricultural input. A south coast where the cows are actually walking in the water right near where the water's abstracted to go to the town water supply. And regional New South Wales, where the waterways can be intermittent, and even in dry periods where they're not impacted by rainfall, that this could be quite a normal context of highly turbid water with different sources. So in this case, we want to know for these different water sources, what's the level of contamination and how do I tailor the treatment to be acceptable to achieve the target? So in a situation where I've protected the catchment, it's wilderness, there are very few inputs, I might need less treatment than in a situation, for example, where the cows are walking in the waterway, and I might need to have more barriers to protect human health. So we need to tailor the amount of treatment to the level of contamination in the water. And what that might look like is for a clean water source, it might be totally okay to just have a screening and a disinfection step, and that might achieve safe water for the consumer. But if the water is highly impacted, there might need to be several steps, including conventional treatment and possibly 2 different disinfection steps in order to achieve safety. And we need to know at each point that each of these barriers is working so that we can be sure that the product is safe. So as we do the risk assessment, we can do it for all different levels of precision. So in some contexts, we might just do a sanitary inspection where might be identifying the sources in the catchment and identifying the possible controls and what should be done. It could go to a risk matrix, which would be scoring if you're used to that type of approach. So it's categorizing different risks as high and low, or we can go right through the quantitative microbial risk assessment where every step of the process we try and put a number to. And this is where my specialty is. And so the examples that I'm showing you today are linked around this because this is what I particularly do. And in that quantitative microbial risk assessment, it's similar to a lot of different types of risk assessment that you might be familiar with in terms of looking at likelihood and consequence. But when it comes to microbes, there's such a diversity of different pathogens that could be involved, and also so many different factors in the environment that we don't know about, that we need to constrain it so that we can define the question towards what it is that we're needing to find out. So we have a specific framework that has been developed by WHO to help us in these different contexts that I'm talking about today. And this guidebook is available online just to download, and it classifies all of the different components. But the key message is really that with this QMRA framework, what we're trying to do is to see what the scientific evidence is telling us about how to manage the water safely. So the pure science, the information about how many pathogens are in different fecal sources. How do they persist in the environment? Are they still infectious to humans? What's the likely disease impact? These detailed, important scientific questions we can then incorporate together to help us understand what that means for managing the system to protect health. And with the WHO guidelines, they use these this risk-based approach for the whole diversity of exposure pathways. So if we think about sanitation, reuse, possible contamination of water sources, and then recreational use or cultural use of water environments, all of these different pathways can contribute to our risk of illness. And in each of these black marked contexts, the WHO guidelines use this risk-based approach to ensure that we define a target, we have a plan, and we're controlling that plan in order to achieve safety. So to have an example from water safety planning first, from drinking water, this is how this specific plan can be defined and set up in order to be managed. And this is what happens, this is in our law in New South Wales, that all water supplies have to have this. We have this in Sydney Water, of course, but it's rolled out in different contexts all across the world. And the idea is you assemble your team of experts, you look at your system, you describe it. What are the hazards and risks? What are my opportunities to control them? Do I need to upgrade my system so that it's safe? What different steps in that system should I be monitoring to ensure that it's safe? And then how do I set up my management actions and procedures so that this is an ongoing safe system? And I thought I'd use an example. This is a very specific example that I thought might be interesting to you today, and that's to think about disinfection byproducts and climate change. So this is one of our big challenges moving forward, is how are we going to be continuing to provide safe drinking water, resilient water sources, when we see the climate changing? We don't know exactly how it's going to change, and we need to be prepared for what is going to be happening. We've noticed these factors that I'm talking about here in Sydney. We've had a lot of rain over the last 2.5 years, more rain than we can ever remember, and our water sources are full of organics, and it's looking like it's going to take a long time for our water sources to recover. And so this particular case study points to something that we're dealing with now, but also in many parts of the world. This points to, I've got this a little bit out of order, but the next, this is a really nice diagram which I picked up from this publication, to just give a quick snapshot of the idea of disinfection byproducts. So we disinfect drinking water to inactivate the pathogens to protect health. But around the 1970s, 1974, it was discovered that when we add free chlorine to water which has organic matter in it, we form these different compounds which are referred to as disinfection byproducts. So I'm talking today in this case study about trihalomethanes, so chloroform and bromoform and other trihalomethanes. It's a total group, but there are others that are formed as well. So the idea is that we disinfect to protect health, but then there's a concern that if we're forming too many of these chemical compounds, we may be leading to other health impacts. So this was a big discovery in the 1970s, and there's been an enormous amount of research done on this in many different contexts. And I would have to say that I think it's still very uncertain the extent to which these chemicals are impacting human health. Toxicological studies show impact on animals, but how that translates to humans, there's studies that show an impact and studies that don't show an impact. So there's still many questions that need to be answered in this area. But back in 1978, at the beginning of this kind of research, this was the concept that people were thinking about in terms of a risk trade-off. So the microbial risk in drinking water is the most important. We need to control the acute risk of people becoming sick. That's the most important. And as you increase chlorine, that microbial risk decreases very quickly. But then the concern was that at some point, as represented by the dashed line, the chemical risk is increasing with dosage. And at some point you reach a risk trade-off where you need to decide that that is where you're going to dose your chlorine for the most effective health outcome. So in this case study, what we aimed to do, and this was done a few years ago now, but it was about 2012, I think. We aimed to do modeling to reproduce this figure. So this figure was an idea and a concept, and what we aimed to do was quantify it and to say, well, what would this really look like? So we looked at our whole risk assessment and we compared through that risk assessment both pathogens and the disinfection byproducts. So in our source water, there would be pathogens that need to be inactivated, but there would also be organics that are precursors. We have some removal during treatment, and we have some formation of the disinfection byproducts. And then given their exposure, the dose and the exposure to disinfection byproducts, we have a certain probability of infection from those pathogens that are still there. But then we had a certain likelihood of negative disease outcomes. And the disease outcomes that we were looking at for disinfection byproducts here were bladder cancer. So in this particular situation where we had a highly impacted river, conventional treatment, filtration, and then chlorine disinfection followed by storage, we looked at the overall pathogen reduction for 2 bacteria, 2 viruses, and 2 protozoa. And you can see here with the white, for the 2 bacteria and 2 viruses, this log reduction achieved by disinfection was very important. It's a big amount of the safety. For the protozoa, less so. But in all these situations, the treatment process was effective for removing the pathogens. Over the year, using predictive modeling of disinfection byproducts, you could see that for different months, the predicted trihalomethane concentration increased over the summer in Europe and then decreased. Depending upon the dissolved organic carbon, so the organic load, it was higher or lower. So this is just representing 2 different types of model, 2 different models from different research groups. And so as we aim to reproduce that figure that I showed you previously, and I've represented bladder cancer here in the red, and then each of the different pathogens in the gray, the trade-off point was very low compared to current dosage. And if I zoom in on that so we can see even more closely, you can see where the trade-off could be. So these kinds of modeling exercises can help us protect health, but they're based only on the science that we have. So the more pure science that's done, the more that we can understand more clearly where that trade-off is. And if we were to look at events, so this is rainfall events, and if climate change means that we're going to have more events, this figure on the left says if we have 12 events per year or 12 event days per year versus no event days, we see the risk of cancer increases because of the organics, and we might change our risk trade-off, our chlorine dosing point.
Prof. Suzanne, please, can you wrap up within 1 minute? It's almost the time.
Okay. So I have other examples to show you from wastewater reuse, sanitation, safety planning, and recreation water, which I won't have time to show you. But this is the same approach that's been applied in different contexts. So when wastewater is reused, so for example, with the biogas, people can be exposed, and we can use this approach in order to protect health. And similarly, when we come to recreational water, bathing waters, we can set up the same process of a recreational water safety plan to ensure safety. So as we approach 20-year anniversary of water safety planning, there's still an enormous amount of work that needs to be done to support management, both from the side of the pure science to help us to understand the pathogens better, how they're behaving in the environment, and the risk trade-offs from different management decisions. And we also need to understand better how climate change and how the need for resilience is going to impact upon our plans in the future. So thank you.
Thank you, Dr. Suzanne, for your nice presentation. Please, now we have 5 minutes for questions and answer. So audience here, we are looking forward to hear from you. Any questions?
We have online.
Okay, please, Dr. Manar, proceed.
Dr. Suzanne, this is impressive what you are doing in terms of research for water and health. And what is about the international collaboration? If anybody is interested, if they will comic the experience that you have done, but in the Middle East area, or maybe in North Africa, is there any collaboration you have done that you shared these results and it could be applicable in the context in this part of the world?
I would like to share with you the Global Water Pathogens Project. So it's the GWPP, and the website is waterpathogens.org.au. And if you go to .org, and if you go to that website, you'll see a really lovely collaboration between an enormous number of scientists working in this space from all over the world. And it's a very open network to researchers who are interested. It's talking about, there's a lot of great scientific information on that site, and also case studies, and there's opportunity for you to comment on those case studies or provide your own, or to reach out to the network that's part of that. So that would be the collaboration that I would recommend to you. Yeah.
Any questions, Dr. Manar?
Oh, from the online, it's okay. I'm just checking. It's many comments thanking Dr. Suzanne with the very high profile. You are a source of inspiration, Dr. Suzanne. Maybe I will ask you a question. How do you manage? I know.
I think you just got cut off there. Or have I been cut off? Have I lost you? Do we have a thumbs up or?
Okay, I'll repeat again.
Am I back again? Okay, sorry. Yes.
Okay, again from the beginning. This is Mayada Bardan, Head of Research and Studies at Sharjah Electricity, Water and Gas Authority. The GCC in mainly and Australia rely a lot on water desalination. So I want to ask how we can collaborate in order to study the impact of water disinfection on desalinated water in terms of byproducts and trihalomethanes, bromate formation.
This isn't something that I have really worked on, but I would welcome the discussion about it. Desalination is obviously has been important in the Middle East for a long time, but is increasingly so in Australia. I think we've been slower to pick it up. And this is going to be something to think about moving forward. I think the reverse osmosis process that we've been using does protect us from the precursors of disinfection byproducts, but there's still a lot that we don't know about what may be lurking and we may need to consider. So I think that's a very interesting and important question.
So any case studies, any research in this, is highly welcome to share and, work on.
Thank you.
Thank you.
Okay, thank you, Dr. Suzanne. Actually, it was very interesting topics, especially with the problem of water. And we know that it's rare and have many problems with these things. So can I just ask a question? What the most challenges that you faces when you go into or when you start to work with the safety of water?
Well, I think I'll have two answers. One is scientific and one is practical. I think the scientific challenge is my first degree was in engineering. And then, so engineering is very pragmatic and practical. But then when you come to answer these really difficult questions, the science is very important and very intricate. And so there's just so much to learn about all the different components of the work that's going on. And many of these things can't be simplified. So I think there's just so much we don't know and so much to learn. And then I think the practical difficulty is, well, in Australia, I think we increasingly need to look at purified recycled water, which is recycling back into our network to conserve resources. But I think we're at the stage where we know how to do it scientifically. We know how to do it practically to protect health. But I think it's a human component of whether people want systems that are set up that way. And so then the interaction between the science and the engineering, but actually people and community and what they want, I think is very challenging and interesting and of course important.
Thank you so much, Dr. Suzanne. Actually, it was a pleasure to have you today with us.
And Dr. Suzanne, there is many thank you note. I need to tell you there is a DIWA thank you note asking, thanking you for the interesting and insightful presentation. And there is also a comment from Tunisia, Dr. Rima. She's very interested in your presentation. And there is also a comment from Dr. Noha. Do you have research related to water analysis for determination of impurities and water purification?
Well, I feel like a little bit of a cheat because, or that I don't know if that's the right word to use, but I spend my time reading other people's research and then try and understand what it means for health. So in terms of doing the analysis myself, no. So I'm involved in helping determine what analysis should be done, how we should set up the program, but then figuring out how will that impact our policy, our decisions, what we will do with the water. So I haven't got any personal research in the methodologies that I can share with you.
I think Dr. Bashriya, we can move to the next one. Dr. Suzanne, I can assure you many thank you notes from different parts of the world: Tunisia, Oman, Saudi Arabia. Dr. Sylvia, I'm not sure where is she's, but she also thanked you for interesting speech. Many thank you note for you, Dr. Suzanne. You are a role model for our women in research.
Thank you so much,
Dr.
for
having me.
Thank you so much. It was a pleasure to have you today with us.
Thank you.
So now let's go for the second session, which will be presented by Khulud Al-Minai. Khulud Al-Minai is a researcher at Dubai Electricity Water Authority, DIWA. Khulud received her bachelor in mechanical engineering from University of Birmingham, United Kingdom. She has completed her MBA in general management from the Canadian University in Dubai. Khulud is a part of 4IR section, specialty robotics and drone in research and development. Her current research topics include development of robotics solution for air attenuation measurement for CSP and Lambertian target testing. Now with Engineer Khulud and session entitled Autonomous Rover for Albedo Measurement. Khulud, the floor is yours. You have 20 minutes for your presentation.
Good afternoon, everyone. I am Engineer Khulud Al-Maini, an R&D technologist in DIWA. So in my today's presentation, I'll be talking about one of our projects in the R&D Center, which is Autonomous Rover for Albedo Measurement. Before we start, I would like you all to join me to watch this short video about our project.
The Research and Development Center supports Dubai Electricity and Water Authority, DIWA's efforts in innovation. That is a key pillar of its work, by applying the best international practices in R&D. As part of the efforts to improve operational performance of bifacial PV panels that has solar cells on both sides, front and rear, this innovative method has improved efficiency as well as reduced costs. Albedo measurement calculates the diffused reflection of solar radiation out of the total solar radiation received on surfaces. The traditional method to measure albedo relies on a technician with a sensor to walk around in the site to record the albedo readings. It is preferable to install bifacial PV in areas with high albedo to ensure maximum output from the panels, but the homogeneity of the albedo measurements is also a factor. Traditional method is time-consuming, labor-intensive, and highly prone to inaccuracies due to human errors, such as maintaining accurate coordinates. To overcome this problem, an autonomous rover was designed, built, and assembled at R&D labs to measure albedo effectively. The rover is equipped with a robust algorithm for autonomous navigation, as well as albedo data collection. Furthermore, an easy-to-use mobile application was developed to conduct site missions and store the data. This innovations made at DIWA's R&D has the potential to be more efficient, faster, and can effectively contribute to DIWA's technological advancement.
Moving on to our presentation. So as you all have seen, this was a short video explaining our project that I'll be talking about, which is Autonomous Rover for Albedo Measurement. Our presentation outline is as follows. We'll start with an introduction, moving on to the problem statement, objectives, and we'll discuss the methodology and prototypes, and we'll conclude with the experimentation and testing. So traditional PV panels are monofacial and generate electricity by harnessing the sun radiation when it strikes the top surface of the panel. However, the panel is not capable of capturing all the sun radiation, especially when it comes to the reflected diffused radiation from the ground, as well as the percentage of the radiation that goes unused. The newly designed bifacial panels, as you can all see in the picture in the slide, designed the panel to allow us to capture the ground reflected radiation, which increased the total output produced by a single panel when compared to the conventional PV panels. The higher output is possible as it composes of solar cell placed back-to-back facing both sides. Unlike the conventional PV panel in which the solar cell face only the top. Using the bifacial panels allow us to reduce the number of panels placed. And one of the most factor that is crucial to the PV panel, to the PV panels is the albedo. The albedo contributes for bifacial panels, which is measured by the panel tilt angle, considering there are no obstruction. The output from the bifacial surface is highly dependent on the albedo of the surface. The albedo, or the whiteness, is defined as the proportion of light reflected from the surface, which is range from 0 to 1. Surfaces like snow has a very high albedo of around 0.95, since the surface is close to white. For desert surfaces, which has an albedo of 0.35, making the desert suitable location to place the bifacial panels. The albedo normally is measured using an albedometer, as you can all see in the slide. It is measured using the ratio of reflection radiation to the incident radiation. One way, I would say the instrument consists of two pyranometer. So one at the top here, which is facing toward the sky, and one toward the ground, facing the ground. The albedo is then calculated from the ratio reflected radiation and incident radiation. For our project, we chose with the autonomous rover, which enables automation of tasks, which increase efficiency. The autonomous rover has many other applications, such as Mars exploration, agriculture, security, site inspection, site survey, etc. It provides a robotics platform that allows customization based on the user's requirement. The advantages of using these rovers are a lower cost, less labor intensive, completely customizable based on the user needs, and they are used in situations where it is harmful to people. And most importantly, it can operate without human intervention in fully autonomous mode. Albedo measurement using autonomous rover is a way of getting high resolution albedo measurement quickly and accurately. These readings help create a detailed surface albedo map that can infer for construction of bifacial PV panels. Moving on to the problem statement and objective. For the problem statement, the bifacial module output is dependent on the albedo value of the area of installation. As a result, it is very crucial to have a detailed surface albedo map of the location before the installation of the bifacial PV modules. Currently, a person walks around the site to record the albedo data. The collected data always has a certain percentage of error, caused mainly due to varying sensor height and angle, as well unable to follow the exact coordinate of the area. And it becomes impossible for a person to walk around and get the albedo measurement, especially if the area was very massive. This project aims at making this task easier and quicker with accurate data collection using autonomous rover. The autonomous rover is capable of following a specific set of waypoints to collect the data, which reduce the human intervention for data recording, resulting in the data to be more accurate. Our main objective in this project is to get the albedo measurement for given area using autonomous rover. And we aim to achieve mapping the area to be surveyed for albedo readings in an S-shaped path. And the data would be collected and stored on a database for easy access and understandability. And finally, to develop a mobile application to control the autonomous rover, as well as a platform for viewing data collected by the rover and a final albedo map as an output. So moving on to the methodology that was used and the different prototypes in the project. In this project, before applying the albedo sensor for measurement, the autonomous rover has and was designed and built and tested in the R&D center to see if it's compatible in the desert terrain, as well as to test its autonomous capability. So before applying any components for the albedo sensor, we tested the rover and to make sure that it does have an automation capabilities. The rover comprises of two major components. So we have the electrical components and we have the mechanical components. The electrical components provide the necessary information required for the autonomous functioning of the rover, and the mechanical component to support the maneuverability of the rover. For the rover body, we used aluminum as the material. In our case, aluminum is the best option as it has the strength as well as it is a lightweight material. These properties enable the rover to move smoothly and do not overload the motors. The bearing, as you can see here, is implemented to provide maximum support for the wheels and the body for smooth movement in the desert terrain. It also helps with the precise alignment of the wheel. The wheel selection was also taken into consideration to have the maximum traction. The design of the rover provides sufficient ground clearance for its easier movement. So now we will discuss the different prototypes that the rover has been through during this project. The first prototype, this is consisted of a simple wooden base, had four DC motors controlled using Arduino microcontroller paired with the Sabertooth motor driver. It helped understanding the workflow and procedure as to how smoothly integrated the components. The second prototype, this was an upgrade from a simple base to a box-like compartment with addition of a new component to control and navigate. We had the Pixhawk's flight control unit, GPS antenna, radio telemetry, and remote controller were installed. The drawback of the design was less support to the motor shaft that caused eventual breakage. For the third and fourth and fifth prototype, the box-like design was changed to a sleeker design. The mechanism of attaching the motor shaft to the wheel was also improved by utilizing two bearings and a collar lock. This proved to be highly effective in providing increased support, rigidity, strength, along with the smooth movement on terrains. The drawback of these design was the absence of an effective suspension system. This caused vibration to the rover during navigation. So this was our final prototype in this project. In this prototype, the problem of suspension is resolved by implementing a variation of rocker bogie mechanism to the chassis design. It is a six-wheel drive mechanism, each of the wheels driven independently. This ensures that there exists at least 4 points of contact to the surface terrain when in motion, making it highly stable. Furthermore, it is also suitable for uneven terrain. The front two pairs of wheels rotate along the horizontal axis, while the rear wheels rotate along the vertical axis. These are all connected using a T-shaft bar of cylindrical diameter of 2 millimeters in diameter. For the motor casing, a hollow cylindrical structure was designed. The wheel shaft designed to fit on the 16-inch wheels. The material used for the T-shaft and beams was aluminum 111 series. And for the motor casing, a lighter material was needed, and we used the stainless steel. In our experimentation, several experiments actually were taken for the S-shaped navigation and data collection were carried out. The location of experiment was location as shown in the slide. Basically, it was in the R&D center, and to be specific, it was in the 3D printed lab. And for validation of the accuracy of albedo data collection by the rover, a comparison experiment was made between the rover and the conventional method. So the albedo was calculated post-experiment. The pyranometer sensor located on the rover were kept at the same position to measure the albedo right after the solar cell. So on the left-hand side here, we have the albedo measurement using the a normal traditional method using the albedo meter. And here the albedo were calculated and measured using the rover, autonomous rover. And finally, at the end of the project, the team has developed a mobile application for setting missions, for site assessment, viewing, saving data logs, viewing the rover location, and a few other features. Thank you.
Thank you, Khulud, for your interesting presentation. So now it's time for questions. Dr. Manar, if you have any questions in the online.
So
please.
far, all thank you notes for Engineer Khulud. I'm impressed with Engineer Khulud. You are young and talking in very deep technical way and conducting experiments and designs and checking and testing what's going good and if it is not good, you are improving the design. We are really very proud of you. So far, all thank you notes. Dr. Bishriye, please check the audience.
Okay, audience, any questions, please? So if there is any questions, can I ask Engineer Khulud? First,
Yes,
thank
sure.
you.
Go ahead.
Thank you so much for your presentation and work. It was really impressive and very nice. I want just to ask one question regarding the albedo. So in general, there is a difference in the albedo of radiation depending on the site around here. So do you think the amount of albedo that is already reflected or the reflected radiation from the desert, it's very high? Or do you measure that amount depending on the ground around it?
So basically, as I mentioned, the desert normally has an albedo measurement of 0.35, which is actually not very high. So the more white the surface is, the higher the albedo, the higher the output and the reflection of the radiation will be. So that's why we in the R&D center, or I would say in Mohammed bin Rashid solar park, they normally go for bifacial panels. So they don't just depend on the radiation that comes from the sun directly, but the bifacial panels also help us to have and collect the radiation reflected from the ground as well.
Another question, if when you compare the efficiency of the bifacial and the normal one, can you have a figure how much the increase of the efficiency?
Yes, actually, it can be like, it can come up to like double of the energy output, yes.
Oh, that means the albedo is very high because as you said, it's already depend on it.
Exactly. I don't know if anyone has heard of Shu'a Energy project that is going on in Mohammed bin Rashid Solar Park. So mainly it comes in different phases. So they started out with producing 300 megawatts of electricity, and now mashallah, it came to its fourth phase and it's producing around 900 megawatts. And basically in this project, we've been using all bifacial panels.
Mashallah. We have another questions, 1 minute.
Assalamu alaikum.
Yeah.
Actually, I'm directing this question to Dr. Manar. First of all, I want to thank you, Dr. Manar, because it's my first time to participate in this conference. My name is Dr. Rasha. I am from Higher Colleges of Technology, and I'm noticing that the women can do good research. We need this forum because it's a start to have a pool, as you said, of researchers. And my suggestion is that if I am still alive till the coming year and participate in this forum, I would like to see there is an opportunity for opening patent files and give us projects that has high impact on the society, where we can participate with a team of women inside and outside UAE. So if this is another contribution to this wonderful grouping, I'm sure that women will have impact in research. Thank you, Dr. Manar.
Inshallah. Thank you.
Thank you, Dr. Rasha, for the acknowledgement and the great words of encouragement. We feel happy and we feel more motivated when we hear these comments, and it makes us really feeling that we are doing the right target, the right platform, and the right forum to hear all your voices. I will pass the mic for Dr. Mohammed Al-Himeri, the head of technology transfer, who is the expert in patents and how we can take your suggestion forward to empower our women to file their patents and their inventions.
Thank you, Dr. Manar. I didn't hear well about the question regarding the patent, but if you are asking about filing patents, this is usually what we do when we have potential research outcomes. And this research outcomes is novel and has industrial impact or industrial application. So usually there will be some kind of due diligence that we do. We call it a patentability research report. And in that report, we will know if this invention is satisfying the requirement and eligible for patent filing. Can you repeat your questions about the patent, please?
Thank you, Doctor. My question was that if there is pooling a team of women to work on a high impact prototyping grants where we can open patent files, and then we have this code of the patent. So this is a start where we can have collaboration with the industry inside and outside UAE. Thank you.
Thank you. Okay, so, well, the patent is a mechanism to protect the intellectual property for any research project, and it will enable you to do marketing and commercialization of any invention. But it's not a must, or it's not necessarily if you have something like has a breakthrough and you want to commercialize it, you make a fabrication facility and want to sell it to the market. But it's help, especially in areas like engineering, medical, especially for new drug formula, etc. But in usually universities, they have an office for IP and technology transfer. This office will handle protecting the intellectual property for any inventions and breakthrough. And then they will help them to commercialize it either by having a startup in the university or maybe license this technology to a manufacturer or to the industry they will do the development and also the massive production of this invention. We have, as the University of Sharjah, many joint applications for different projects and with different research group in UAE and also international. And we together, through this joint application, we do filing, protect the IP, and also try to commercialize these kind of inventions. So if you want to work with any of universities in UAE, including University of Sharjah, we will be happy to collaborate and also protect the patent application you have. If you have any other questions regarding how to do filing or patenting, I would love to give you and elaborate in details, inshallah, after the session.
Okay, thank you, Doctor. And thank you so much, Engineer Khulud. And now we go into the next session with Engineer Noura Al-Hammadi. So Engineer Noura Al-Hammadi is a senior research and development technologist at Dubai Electricity and Water Authority, DEWA. Noura received her bachelor degree from the Sustainable and Renewable Energy Engineering University of Sharjah in 2014. Her research interests include zero building and building integrated photovoltaic. Engineer Noura, she will join us today, inshallah, in a session entitled Building Integrated Photovoltaic in Hot Climate, Experimental Study of CIGSC, and CS models in BV, which is Building Integrated Photovoltaic Ventilated Facade. Engineer Noura, the floor is yours. You have 20 minutes for presentation.
Thank you, Doctor. Assalamu alaikum, everyone. I'm glad to join you again. In my presentation, I'm going to give you an overview on one of our main projects here in the center, which is the testing and verification of building integrated photovoltaics in hot climates. I'm going to focus on one of the experiments under this project, which is the analysis of crystalline silicon and CIGS types of solar panels while integrated as the exterior walls of buildings. In the next slides, I'll give you an overview on the concept, the goals we worked on achieving, followed by the methodology and results, and finally a summary on our future research plans. We all know that as population grows, the energy demand increases. In Dubai, for example, buildings consumption currently account for 70% of the total generated electricity. Coming from the energy efficiency research area, our objectives align directly with the UAE's vision, and specifically the clean energy and green growth pillar, which is a strategy that aims to increase the integration of renewables to 50%, but also aims at optimizing energy use and reducing the consumption by 40% by 2040. Electricity can be generated in centralized power plants or can be generated at the location where it's consumed or close to it. The latest is called distributed energy generation. Its advantages include the reduction of transmission losses, flexibility, as well as supporting utilities like DEWA and reducing the peak or highest demands of electricity. In cities, and especially in this region, photovoltaics is one of the most suitable clean distributed energy resources. There are two types of PV installations in buildings: building applied photovoltaics, BAPV, and building integrated photovoltaics, BIPV. In BAPVs, we attach the PV modules over already built building surfaces, with electricity production being the main or only objective. The preferred location for this installation is mostly rooftops, and they have several advantages, including using standard PV modules and the installation being at an optimum orientation or tilt angle. However, the roof area of medium and high-rise buildings is rarely enough to accommodate the mechanical systems along with solar panels, and especially the number of panels required to reach the zero energy level, in which buildings produce clean energy as much as they consume across a full year. BIPV, on the other hand, is a promising technology that can add more energy production capacity. Modules can be integrated not only in the roof, but also as opaque and translucent facade or shading elements, like the photos you can see on the right side. These are actually from one of our competitors in Solar Decathlon Middle East, where the team integrated PV as part of the facade of the building, as well as the movable shading panels. So by replacing these construction components, the PV modules become multifunctional. With the additional surface available for energy harvesting, it's considered one of the most promising contributors to zero energy and self-sufficiency. Moreover, it was also concluded in research that BIPV can contribute to thermal loads reduction when integrated as double skin facades or glazing applications that allow daylight harvesting, such as semi-transparent BIPV windows. Multifunctionality also contributes to reducing the payback period of the investment, and the integration enhances the building's architectural expression and allows customization, since the modules can come in a variety of colors, shapes, and transparency. It also provides social sustainability awareness and supports the acceptance of PV in buildings. It's highly attractive for countries like the UAE, where we have high solar radiation, many medium and high-rise buildings, and elevated energy consumption due to the cooling. Nevertheless, the use barriers of BIPV include policies and regulations, such as the implementation of feed-in tariff and the revision of building codes. In DEWA, actually, we're working on publishing the BIPV regulations in collaboration with other governmental entities very soon. Economic, where the user must consider initial cost and return of investment. And finally, others related to lack of information and resistance to change. The modules can be installed during buildings construction or as retrofit for existing buildings. Designing the system requires consideration of important factors such as the material, structure, and location, including surrounding shadows. These factors can affect the module's energy production as well as the temperature. And if the temperature elevates beyond certain rates, it will also reduce the energy production. You can see in the right side image the annual irradiance received at different surface angles in a city in Germany. Irradiance is the amount of light energy received per square meter of a surface. This analysis system design position the PV modules efficiently. The material or technology is selected based on the system rule, as they can vary in the performance, flexibility, translucence, and durability. The performance of each material is also uniquely impacted by weather conditions, the angle of incidence, and irradiance levels. Potential PV technologies in BIPO applications are crystalline silicon, a reliable technology for almost all uses. Polycrystalline silicon in particular is highly utilized in roof tile products. Thin film technologies have lower efficiency rates, yet they're highly utilized due to the flexibility, affordability, better transmitters of light, and better performance under low light. And finally, some options are also less impacted by heat. Emerging PV technologies such as dye-sensitized and organic photovoltaics have also shown promising potential, but efficiency remains an area of development here. According to these specifications, the pie chart below shows the popularity of using these technologies in roofs and facades. After discussing the different opportunities and challenges, let me go through our research plan. Our objective goal is, our overall goal is to support the integration of renewables and enable the zero energy performance of buildings. This will be achieved by identifying the most suitable technologies for the hot climate and improve the research process along the way. In the experiment I'll explain, we worked on comparing the performance of two technologies while integrated as ventilated facade to control the thermal gains. The cube structure you see is part of our outdoor test facility in the Mohammed Barashid Solar Park. We used it to study the energy behavior of CIGS thin film and crystalline silicon technologies. 84 panels were integrated in the most productive orientations for the Northern Hemisphere, which are the South, East, and West. Around the envelope of the cube has open joints, around 8 centimeter air cavity behind the panels, and an insulation layer. The two frameless modules have similar appearance, but different dimensions, different efficiencies, rated power, and temperature coefficients. However, we normalize the produced energy per square meter to be able to compare both. We monitored the energy yield and temperatures for a whole year. Besides technology, the analysis considered the different orientations, the time of the day, and season. To measure the radiance, we installed 3 pyranometers with 90-degree tilt angle in each orientation. For energy analysis, we measured the panel's energy production individually and normalized this based on the area to get kilowatt-hour per square meter. We also placed thermal sensors at the back of the modules to monitor their temperature and use the meteorological data from our weather station to compare both with energy. In the last part, we included device electricity consumption patterns in the analysis. In the radiance analysis, as you can see in the figures, the South, of course, was confirmed to be the optimal orientation of PV installation with the highest annual irradiances. The East and West had similar total amounts, that's about 14 to 15% less than the South. We also observed that the East and West surpassed the South in production during the period from April to August. This emphasized the importance of investigating the significance and contribution of these orientations that could be referred as non-primary. Like the irradiance analysis, the South had the highest overall yield irrespective of technology, which is a summation of the blue bars in the figure. However, during summer, the East and West energy yields exceeded the South by 41 and 33% respectively. Building designers, therefore, must consider these orientations if their goal is to increase energy production or if there is limitation on the use of the South. When it comes to technology, we attested the advanced energy behavior of crystalline silicon with 13.6 higher monthly yields on average. Here, I'm comparing the energy yields of the different orientations with the irradiance and ambient temperatures. The upper figures are from summer and the lower figures are from winter. The solid curves in blue represent the south model's production. The orange is the east and the green is the west. You can easily notice how the high temperatures in summer reduced the yields despite of the higher radiance. Looking at the east and west data, we observed that the difference between the radiance is minimal. It's actually 1.7 on average. However, the average energy yields ranges of the west was 12% less. That's a big difference compared to 1.7% difference in the radiance. The big variation is because across the day, when the sun moves from the east in the early hours of the day to the west, heat gets accumulated in the west facade, especially when the sun is at an optimum angle for energy production in the afternoon. This caused its performance to degrade further. Hence, performance-wise, the east was the second best performing facade. When we compared the mean actual efficiencies with the rated values, we found that the crystalline silicon modules efficiencies were reduced at a higher rate compared to CIGS due to temperature. The theoretical efficiencies differ by 3%, but in real conditions, it was about the half. Also, because of the lower efficiency, CIGS panels were a bit hotter. The difference between both was clearer and more representative in the east due to less heat accumulation. I've mentioned previously that during the hottest and highest energy demand months, the yields of the east and west exceeded the south. We then confirmed that the east was the second best performing facade. However, when we compared the production patterns to the typical electricity consumption profile in Dubai, an example is the dotted line, we found out that the west facade production coincides with Dubai's peak electricity consumption periods, which is from 2 p.m. to 6 p.m. The figures might look complicated, so let me explain. The left ones are the original yields of the cube, and in the rest, I merged the yields of the different orientations and changed the amount of contributions to try to match the consumption profile as much as possible. And by that, our study verified that the combination of the south and the west yield, despite being the least productive orientation, can support buildings in meeting their daily demand while attaining a generation consumption correlation. To conclude, our next activities will be supporting the Shams Dubai program, which will include the BIPV regulations soon, conduct economic feasibility analysis, and finally update the test facility with new advanced modules, maybe more colors. Thank you.
Thank you, Engineer Noura. Thank you so much for your nice presentation. Now we have 5 minutes for questions. So any question, Dr. Amanar, on the online?
So many comments again. Thank you notes from Dr. Khawla Najjar. Thanks for the nice presentation. And many thank you note wishing you the best luck in this project. No questions from online. Let's check with the audience.
Okay, on the floor here, any questions? Yes, please.
Hi, my name is Razan. I'm a fourth-year medical student. So I want to ask actually about applying these panels in the buildings. Is there any chance of reduced safety, especially for families who have lots of children? And second, when we talk about supporting all the daily needs, are we including like charging the electrical devices like mobile phones, laptops, and such things? Thank you.
Thank you. So for the first question, I mentioned that we're launching the BIPV regulations very soon in collaboration with the Dubai municipality and the Dubai Civil Defense. So yes, safety is one of the elements of these regulations, and this includes the safety of installation, the safety of connections, and operation as well. For the second question, my presentation included an overview on BIPV integrated in buildings. However, photovoltaic panels can be utilized to charge or basically operate different devices, including domestic devices and lighting systems, for example. I hope I
Any
understood.
question? Okay, so can I have questions? Nora, please. When you talk about in your presentation, you talk about the building integrated PV, you said that it can be done during the construction and for the existing building. During in constructions, I think it might be more easy because it will be taken into plan or into consideration from the first. My question is, when you make it for the already existing building, what do you think that the challenge that you may face?
Yeah, so Doctor, as you mentioned, in buildings and construction phase, we have more freedom to play with the design and explore different opportunities. However, in existing buildings, this is actually one of the challenges we have in BIPV, where we have limitation on the installations. I think shading elements and facade applications would suit this kind of applications. I mentioned the different factors that impact the performance. So I believe that these are the challenges that building designers will face if they decide to integrate photovoltaics after the building being built.
Thank you so much. Any questions? Again, thank you, Nora. Actually, it was very interesting topic and it's very hot one, especially for the building. We know that the building consuming a lot of energy, especially for the HVAC. So when you use integrated, that means we'll go in the building will be also generating electricity, which is so interesting thing.
Dr. Bashriya, there is a question that just popped up now. My question is about the place of fabrication of the BIPVs presented in the presentation of Engineer Nora.
Which BIPVs you mean, Doctor?
I think she's asking about the location or the place of the fabrication that you made in your design.
A lot of international companies that are leading in the fabrication of BIPV, so that there are different companies that have these solutions available, ready for purchase. And we also have a lot of companies that customize these panels as per the user's needs. I think in Dubai or in the UAE, we have some companies that fabricate the panels locally. However, I'm not sure if it includes different options or colored BIPVs, for example, here. In Dubai Electricity Authority, we're also including the fabrication of PV modules as part of our research lines. So hopefully we'll be able to join the leading companies in the future.
Thank you.
Thank you. Okay, done, Manar?
Yes, we can move to the last exciting session. We really truly thank DIWA R&D, who are our sponsors, golden sponsor for this third year, and for their contribution in the technical sessions. It's massive and fabulous to see the work that have been done inside their laboratories. They have excellent resources and researchers, and we are really doing a great collaboration with them. Thank you, Engineer Noura and Engineer Khulud. I think we move to the last session for today's technical session part.
Thank you again, Engineer Khulud and Engineer Noura and Dr. Suzanne. Now for last session with Ms. Shayma Sharif. Shayma Sharif is leading the innovation program for energy and utilities at Amazon Web Service. She brings more than 16 years of experience working in public and private sector organizations in the Middle East, with an emphasis on building accelerator programs to increase the adoptions and transition to clean energy. Now with Ms. Shayma and the session entitled Leadership and Empowerment for Advanced Clear Energy.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Ladies and gentlemen, it is a pleasure to be here today. I'm sorry I can't be there in person, but inshallah next time. My name is Shayma Sharif, and I work for Amazon Web Services, and I am their Innovation Program Sprint Lead for the Energies and Utilities business. Today, I'm going to talk to you about leadership and empowerment for advancing clean energy. And before I begin, I would like to give a special thank you to Professor Hamid, the Chancellor of University of Sharjah, Professor Muammar, the Vice Chancellor of Research, industry partners and sponsors, faculty, researchers, and of course, all of you students. For today's agenda, I'm going to answer a few questions that could help with telling you a little bit more about what I do, why I do it, and why it's relevant to you. So, what's it like to work for a high-tech company like Amazon Web Services? What's an initiative I've worked on and how it's been empowering? What do I find really unique about my work? And what does it mean to you? Because at the end of the day, it all does come back to you. So I hope I'm able to accomplish something that is relevant and valuable for you by the end of this. Now, before I begin talking about what's it like working for a company like Amazon, first let me tell you how I got here. For starters, it wasn't a straight line. When you look at these photos, as clearly you can see there's no theme here. The only thing in common is that it's all the same person. But I can assure you, I had no idea where I was going. The path before me was not clear. I do know that I was doing my best with the resources and knowledge that I had at the time. And I never stopped asking the question, what am I meant to do with my life? How can I make the most difference and contribute the best, given all the talents, gifts, and resources God blessed me with? I still haven't figured that out. But during the pandemic, I, like all of you probably, started to look at things in a different way. And I decided that, well, since I hadn't figured out what that thing was that I had to do with the rest of my life, you know, sometimes you might watch these videos that say, oh, find that thing that you can't not do. And I couldn't find out what that was, frankly. It is not for lack of trying. So I thought I'd go for the next best thing. I'd follow my curiosity. And during the lockdown, that's what I did. I allowed myself to read and learn about things that I just naturally gravitated towards. And somehow, some way, I came across this thing called regenerative ranching and regenerative agriculture. It's a different management style for how you use the resources available to you to raise food from livestock or food from agriculture in a way that actually builds the soil, reverses soil erosion, builds habitat for wildlife, and fixes the water cycle. And I was personally fascinated by it because I learned that it could also help with reversing desertification, which, you know, coming from a desert myself, I really found that super impactful. And honestly, I watched a TED Talk by Alan Savory talking about using animals to reverse desertification, and like something just dropped. Like there was an aha moment, and I knew right then and there in my room in Dubai, I told my mom, I somehow have to work in this space with these people. I don't know how. I don't know how I'm going to get there, but I have to do something in this space. These photos that you see are taken across for 3-4 years, actually. And there's a lot of learning there, completely different experiences. And trust me when I tell you, knowing what's your why becomes so pivotal when you want to make big life decisions that are going to impact how you spend your resources, how much time you get to spend with your family, and all the challenges and uncertainties that you're going to face in trying to answer that why. So it's very important to make sure that you have one that's really big and grand, and you know that it's going to get you through no matter what difficulty you're facing. Because trust me, when I was working on these branches, and I did that for 9 months, it was not easy. I was in the middle of nowhere. There was no cell phone reception. Sometimes I'd get internet. Electricity would cut off. There were bugs everywhere. But I was there for the right reasons. So it made it all okay. And that's why I'm so excited to speak to all of you today, because I know that a lot of you have a lot of whys, especially the students here, the researchers. You guys are driven by finding answers to questions that you're inspired by, and that's amazing. So hold on to that. And I was very lucky to come across an organizational culture that encouraged that kind of thinking. Let me go to my next question. What's an initiative that I've worked on that I've really found empowering? Well, the AWS Clean Energy Accelerator is one of them. I find this accelerator project empowering because really it's doing something very important. Accelerator programs, as we call them in the Middle East, musarra'at, it's really a way of bringing together two complete strangers for a short period of time and getting them to work together to solve a problem. When I used to work in Dubai and I used to run accelerator programs, I always used to tell people that were new to it, accelerator programs are kind of like speed dating. Like when you think about it in our culture, sometimes back in the day, people used to get married and then get to know each other. And then it was like for life, that's it, you're in it. And when you think about a lot of the traditional ways big companies do business is they put out a bid, they see these are things that we want, put out a tender, and then companies come in and then they bid. Whoever gets it, great, but then it's like a 20-year deal and you have no idea what the dynamic is like. And suddenly you're in this heavy invested contract and now suddenly you guys have to hope for the best that it works. Where an accelerator program is more like speed dating. So you can meet, you can share your values, your challenge areas that you're trying to solve and work together in a short amount of time to see, is there a fit? Can we actually work together or not? Do we have compatible working styles? And this is actually a very important approach to solving problems because it can happen very quickly. And that's why they call it an accelerator, because it actually accelerates how business can take place between big and small organizations. And this is very important because if you look at these numbers before you, these numbers are actually by the International Energy Agency. What you see is that less than 25% of current emissions are going to be reduced through technologies that are up and running, that are mature. And only 35% of an emissions reduction will come from current solutions that are in the prototype stage. Now, a big 40% of the solutions are going to come from technologies that are not in the commercial stage, which means they could be at a lab, you know, with students like you, with universities. They're probably in the pre-startup phase, soon to become startup phase. And it's a very big number. And you see, it becomes very important to make sure that you have successful programs like the AWS Clean Energy Accelerator to facilitate that kind of traction and growth and deployment of these solutions. But I talked enough. So without further ado, I have a cool video to show you about the program. But before I show you the video about the program, you're probably wondering, why now? And why AWS? Well, I hope this video will answer that question.
The world's energy needs are evolving. By 2050, global energy consumption will increase by more than 50%. And the transition from traditional fuel sources towards an increasingly diverse, sustainable energy ecosystem is accelerating. In addition to oil and gas, this new energy ecosystem includes smart electric grids and electric vehicles, wind and solar farms, and hydrogen and biofuels. Energy companies are turning to new, innovative business models to optimize their operations across the energy ecosystem. AWS provides the broadest and deepest cloud platform, helping companies transform the core of their operations today and innovate for a more sustainable energy future. Together with our customers and partners, AWS is continuously developing new technology and solutions which empower energy companies like yours to think big and start small through practical innovations. Our products and services can reduce the complexity, time, and cost of securely gathering information, transforming hundreds of thousands of data points into actionable insights so you can address what's working and what isn't. AWS connects all the distributed parts of your business to create an agile, efficient, and intelligent system of operations so you can make smarter decisions and adapt to what's coming earlier, all the while making the workplace safer for employees and reducing impact on the environment. The world is changing, but the future is here. AWS is how.
I hope that video explains the importance of why taking action now is imperative and why AWS is the right partner to help you in your clean energy transition and digital transformation. So now let me talk to you a bit about the AWS Clean Energy Accelerator. I have a cool video to show you. the startups were selected. Probably asked, okay, Shema, now what? Well, we had a really cool 5-week intensive virtual program that we set up for them. They got technical mentorship, business coaching, and go-to-market guidance from AWS leaders. They got up to $100,000 each in AWS promotional credits through the Activate program to kickstart their data and operations transformation on the cloud. Here's a wrap-up reel for the showcase event in Lisbon. Now, if I was invited earlier, or if this event happened sooner, I would have sent you guys an invitation to join, but maybe next time. We're going to have one next year. So follow my LinkedIn page and you'll know, and I'll definitely get you an invitation to come.
There's something impactful about us being able to connect together after almost a year and a half of working virtually with some of the startups.
So to be able to meet in person and really just celebrate this accomplishment, this hard work that has honestly spanned so many different geographies, so many different time zones, is truly a feat in and of itself.
We were hoping to have hand-in-hand bases with the partners and hopefully accelerate in projects that would add value to the scope of work that we're currently focusing on.
We've made some connections, we've had some real conversations, we're making possibly some new business opportunities and things. So that, I think, for me is it's happening. Like the magic outside and after this has already started to happen for us.
And decarbonization, the energy transition, it is the biggest challenge of our generation. 50% of the technology that's going to reduce carbon emissions either hasn't even been invented yet or is in the proof of concept stage.
You know, we've heard already today the word collaboration so many times. I think it's somewhat new for companies to be able to collaborate in ways that crosses multiple sectors.
We have over 300 companies that have committed to the pledge, and the commitment that they're making is to decarbonize their operation.
Everyone here, I talk to them and I see their passion in changing the world for better.
I found the program very empowering because it was like an embodiment of a philosophy at Amazon that you can have an idea, present it, and then bring it to life. And it all starts as an experiment. We've got these 16 leadership principles, and they act as our guardrails for any initiative that we want to do. And we have to make sure that these initiatives that we are trying to start actually adhere to these leadership principles. When you look at the challenge that we face in the environment today, of course we have to have a role in it. I mean, we're such a big organization. Yes, we have that responsibility to be a part of it. We also have a leadership principle of invent and simplify, and that's what we're trying to do. How can we reduce the complexity to get more and more companies to use and adopt clean energy solutions as a way to fuel our growing energy needs? We're diving deep into the solutions and opportunities that are available in the clean energy domain. We also have this think big. I mean, of course we have to think big. We can't just think in terms of what's in it for me. It's like really the globe. We're thinking of every single person on the planet. How can the work that we do impact their lives in some positive way? And then we have to have a bias for action where you're not waiting for someone or some emergency to happen and then you're like, okay, well, maybe I'll then take action. It's like, no, let's get it done now. Let's work on it. I'm not going to wait for someone to ask me. I'm going to be proactive about it. And that's really why, for me personally, I found it very empowering because this idea suddenly became a reality. And all these people who were there on paper and virtually came together to work on this program because they truly believed in solving a very important problem, which is how do we accelerate the transition to clean energy and deploy it in a way that's more reliable, more available, and more sustainable and more affordable to everyone involved. One of the startups actually was focused on
energy justice by working with low-income communities that didn't have access to the latest, appliances that could have a power mode setting or an eco wash, or they still wanted to be part of the clean energy transition. And with Shifted Energy, they were able to do that, and they were able to become part of this new ecosystem of clean energy. And I was so humbled that our program was able to support them by giving them exposure, by giving them business traction, by helping them expand their digital footprint using AWS. They were able to have a bigger impact. I mean, for me, honestly, that makes all this effort, all the hard work completely worth it. For the third question I wanted to answer today, what I really find unique about the work that I do is this day one culture at Amazon. It's hard for me to wrap my head around it, that a company that's been around for as long as Amazon has, that's as well known as Amazon, it still has this motto, this every day is day one. And that to the point that Amazon's founder and former CEO, Jeff Bezos, would end all of his shareholder letters by attaching the original shareholder letter from 1997, and always end his letter to them by saying it remains day one. What does it mean, this day one culture? It means that you're constantly curious, you're nimble, you're experimental. It means that you're being brave enough to fail, if it means that you're applying the new lessons that you learned as a result of that failure. And these experiments allow us to better delight our customers in the future. And I think as a philosophy, it's really fascinating. And for me to see an organization at Amazon like this PRFAQ, this press release frequently asked questions exercise, that's really about, let's say you want to do an initiative. You write a press release about it. You imagine that, okay, once you launched your initiative and it's all, everyone's like, woohoo, you've done it. What would that press release look like? And then also build a frequently asked questions. Put in all the questions that you imagine people will ask about that new initiative. And imagine, so you build that and then you work backwards from that, which really, I think it's something that we can do in our lives. It's kind of, sometimes you think like having a vision board and stuff, but here at Amazon, it's like we write a lot. It's new for me to be in a company where, for example, with the AWS Clean Energy Accelerator, when I want to do an initiative, I have ideas now that I want to make modifications and iterations to our next edition for 2023. And instead of me presenting it or doing a big presentation like this, it's like, no. You're going to write a document that's going to talk about all the stuff that you're trying to accomplish and why, and who are the stakeholders and what are the considerations and blockers. And it's so interesting because then imagine you start a meeting and everyone is reading this document. Okay. And then they spent the first 20, 30 minutes reading, and then they will have a discussion about the document. So then it's like, okay, everyone kind of read all the details. Now let's open it for questions. It's very, very different for me. And I find that very unique about the place that I work. And it's really teaching me a lot also about this culture of not feeling like I have to have all the answers from the get-go. It's okay for me to say, actually, I don't have the answer yet, but I will go and I'll work to find it. That's part of the leadership principle of earning trust. You don't say you have an answer if you don't really have it. Tell the truth. And, you learn more in the process. So it's like these words that these leadership principles have, it's not just writing on the wall. It's really things that are used constantly in conversation. It's amazing because you're using these standard principles. And, if you go online or on Amazon's website, you can see the definition of the customer obsession and bias for action and all the other leadership principles. So it's not like there's no guesswork for me to figure out, well, what did he mean by So honestly, it's very different for me. And I find that to be in a place where I'm trying to do things in the space of clean energy, it's very, very important because it's an important problem to solve. So what does all this mean to you? Well, at the end of the day, it does all come back to you. And as I said in the beginning, I'm really giving this talk because I hope in some way, by sharing my story and sharing my experiences, it'll help you break through some of the fear barriers that you might have
as a student. You know, there's all this pressure, like you have to have all the answers, you have to know where you're going, you have to figure it all out. As a researcher, everyone's constantly wondering, oh, where's this going to go? And, you know, they're constantly like distracting you from your why. And it becomes so important to overcome these fear barriers, because they're never going to come at you and say, hi, I'm fear and I'm here to keep you from doing something amazing. It's always going to say, oh, what will people think? It'll come in the form of, oh, but how is this going to make money? So really, you have to be persistent and moved by your why and your reason for why you're doing the work that you do. Really work hard. Not give up when things get difficult, because trust me, they will get difficult. It's like God's testing you. Like, really, do you want this? Are you sure? Because I'm going to test you. And you need to know that unless you have a noble reason, a noble why, a powerful why, you're going to quit. Just like, you know, those New Year's resolutions. How many of them we start and then we don't finish by February, March, we've like dropped them. It has to be so powerful to keep you through the good times and bad and the challenges, to keep going at it. In life, you want to look back and you want to say, man, I don't regret that I tried that. But you're going to regret the things that you don't try. What Jeff Bezos is saying here resonates, I think, with all of us. And many people have said it throughout history in one form or the other. It's about taking chances and doing the things you believe in, even if they'll blow up in your face. But at least you did them, and then you found out, okay, that wasn't for me. As opposed to letting your fear dictate the choices and the decisions that you're going to make in your life. So in the end, I just want to tell you, follow your curiosity. The path ahead will not be clear. It's not going to have easy signposts, but if you follow your curiosity slowly, you're going to start to get closer to the answers that speak to your truth, that get you closer to answering your why. And in case you're wondering, yes, that is my hand. And as you can see, I've got the scar I got from my time on the ranch, as I call it, my little souvenir. And I looked at my hand while I was in the field covered in dust. This was in Mexico, and we were moving cattle, and I realized, man, look at my hands. Like this is a far cry away from Dubai and going to get my nails done, and I couldn't get my nails clean no matter what I did. And you know what? I loved every minute of it because I knew I was there for the right reasons. And I urge you to be ready to do the hard work that's going to be required of you when you are seeking answers, questions that you find meaningful. So thank you so much, everyone, for your time today. I really enjoyed connecting with all of you to speak to you more about the work that I do and for being able to share some ideas with you. Please feel free to connect with me on LinkedIn by scanning the QR code. And inshallah, I look forward to meeting you somewhere around the world in person. Take care. Bye.
Thank you so much, Ms. Shaima. It was really interesting talking, and it's we want to have many questions, but unfortunately, because of the time, we have limited of time short. So please, any questions, you can just please scan the barcode for Ms. Shaima, and you can ask her. Now it's time for closing this session. Thank you so much for being here with us, and we're coming for the next session, inshallah. Thank you.
Good afternoon, everyone. Today we are gathered here to celebrate women who have chosen to work in research. We are recognizing the meaningful contributions women are making every day to research and discovery. It's also a day to inspire future women researchers, scientists, and artists. On behalf of the organizing committee, I'm very honored and proud to invite you to explore the poster session featured in the hall outside that shows women's achievement in various fields. This year, the forum accepted submissions from UAE, GCC, and other Arab countries, and I'm proud to announce that more than 379 outstanding women researchers from 64 universities submitted their research projects. The submissions covered 3 major categories: 1, engineering, computing, informatics, and science; 2, medicine, health science, dentistry, and pharmacy; and 3, arts, humanities, social sciences, as well as communication and business administration. More than 50 jury members helped evaluating the submitted projects, and 22 grants will be distributed for winning teams shortly. Next year, the forum will expand internationally to inspire a larger number of women to contribute with their knowledge and skills in solving real-world challenges. Finally, we are all very proud to witness the expanding women's involvement in research across different fields, in spite of so many daily challenges, like maintaining a work-family balance. So on behalf of the organizing committee, I thank you all, and I invite you to the hall to explore the poster session. And after that, the winners will be announced. Thank you so much.
Dr. Nargis, Prof. Dima, are you around? Yeah. Okay, till the time that they will join on the stage, please, everyone, can you get closer in the front rows? We would like to see your bright faces. We would love to see your energetic power at the end of the forum. Now the time to announce the winners. Dr. Nargis and Prof. Dima, you are making high suspense for the audience. Can you come even closer? Still, I can see some. Come to the front rows, please. And again, on the online, we have more than 260 participants, attendees, who are also waiting to see the results. Zubair, can you put
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. I want to say first, congratulations to everyone for this amazing forum. I attended the morning sessions and I learned so much. I was inspired, and it's great to see these initiatives and this momentum at the University of Sharjah. Congratulations, Prof. Muammar. Congratulations, Dr. Manar, and the entire organizing committee. I think this was beyond the expectations. So now, after a long day, we reach the end of the day. And I think the most important session that everyone is waiting for, which is the awarding of the grants. So I want to see if you're ready and excited. Everyone is ready for the grants and the awards. Yalla, I want to see some excitement. So we have 22 grants to announce, and this speaks a lot to the efforts of the organizing committee in raising these funds to support women in research. I want to take the opportunity to thank one more time our partners and our sponsors, our strategic partner, NAMA, and our gold partners, SIWA, ADNOC, DIWA, Emirates NBD, and Pfizer. Let me conclude and turn it over to my colleague, Dr. Nargis, but I want to conclude with one word, that everyone today who took part in this forum, who made a submission, all of you are winners, irrespective of the 22 who have been shortlisted, who will be awarded, but it is the courage and the initiative to submit, to undergo a review, to have yourself exposed to peer review. This is really what matters. So I want a big round of applause for everyone, because everyone is a winner. So I will leave it just here, turn it over to Dr. Nargis, and she will be announcing the awards.
Thank you, Prof. Dima, and thank you, everyone. So I'm Dr. Nargis Hassalam, Assistant Professor at the College of Business Administration. I'm happy and thrilled to be over here to announce the winner of this forum. So this year, we received around 380 high-quality applications from the UAE and the GCC University, almost double last year, in fact. So it shows how the forum grew up. And we had more than 50 judges who reviewed this application to shortlist a 21 project. This 21 project will share the amount of 250,000 dirham. So for this year, the winners are divided in 3 categories. Category 1, health sciences and digital health, pharmacy, medicine, dentistry, bioinformatics, and biomedical engineering. Category 2 include engineering, sciencing, computing and informatics, and other disciplines with a contribution to science and technology. Category 3 include art, humanity and social science, communication and business administration, and social science contributing to the engineering. I know Dean Dima already asked you to join us for a round, of applause to all our winners, but I'm gonna ask you to join again and to applaud them for all their hard work, please. I will ask you for a lot of round of applause, so be gentle with me. Another one for the organizing committee. Lady, can you stand up, please, if you are here? And I want a very big special one. Okay, so get ready. So this very big and special one go to Dr. Manar. Where is Dr. Manar? Where is Dr. Manar? So this amazing lady, wonderful. She's the chair of this forum. She's a dear colleague to all of us. And believe me, without her leadership and contagious smile, you won't have this forum. So a very, very big one for Manar. Okay, now you practice it well. I guess you're ready for the winner. Are you ready? Okay, so what I will do first, allow me to call Prof. Muammar to the stage. And then when I call your name, please come to the stage to receive your prize and be prepared to say one sentence. One, okay? Because we have 22 and unfortunately we don't have that much time. So one sentence to describe your project. Okay, then let's start. The winner for the category 1, from the category 1, Prof. Insania Abunil, Dr. Sumaya Sheila, Fatma Musa, Ifti Ahmed. Can you please come to the stage?
And it is 20,000.
First of all, I really would like to thank you all for giving us this great opportunity to present our work to this amazing forum. And actually, our work was on using glass microspheres for like odontogenic, osteogenic application. And shall I say enough?
One sentence.
Thank you. Thank you.
Thank you. Mabruk. Our second team, Asha, Caroline Cyril, Rajan, Radakishtan, and please excuse me if I mispronounce the name. There is a lot of complicated name in my list, I'm scared. And Yosra Lozoun, Najma Ali, Anaka Barampash.
First of all, I would like to thank you at the forum for giving this opportunity. And our work is on statin-induced myalgia, where we study the pain channels that get expressed when statin is given chronically. Statin is a drug that we commonly use. So I think that's enough. Thank you so much.
Thank you so much. The third team, congratulations. So the third team, Dr. Fatma Taher and Nama Barakash. Maybe one sentence?
Yes. She's ready for the
Thank you. Thank you, Hondi.
Congratulations, Dr. Fatma. Our fourth team, Dr. Soli Bougie and Dr. Ubada Khatib and Dr. H. Lim Lim.
I think they are online.
They are online, right?
Can you put them on the Zoom, please, Zubair?
Dr. Soli?
In online, we have 264. Can you raise your hand so that we can allow you to talk? Dr. Soli? Yes. You can talk, Dr. Soli.
Thank you very much. I've just reached UAE. I was out actually attending a conference which was Can you hear me?
Yes, yes, we can.
Thank you so much for this award. My proposal is basically aimed at earlier detection of the Parkinson disease in individuals. it is extremely important, as early detection and timely medication can help improve the quality of life of the patient. So this is what we are looking at. We have done some groundwork, and this fund is definitely going to help us work further, and looking forward to collaboration with further industries in the UAE medical field. It was a wonderful session. I've been online for some time now, and it's very inspiring, and I congratulate everybody involved, especially Dr. Manar, University of Sharjah, for organizing such a fantastic forum. I'll see to it that I would be present next time. I can't afford to miss such a beautiful forum. Thank you so much.
Thank you, Dr. Soli. Congratulations. Congratulations. Thank you. So our fifth team is Dr. Mariam Nafi'i, Sahar Atalhi, and Dua Al-Awafi.
And they are from Saudi Arabia. So
Yes.
can you back to that? From Taif University from Saudi Arabia.
Are you with us?
Yeah,
Or
they are
online?
online, I'm sure.
Online?
Can you raise your
Doctor?
hand so that we allow you to talk?
Dr. Maria?
What about the video?
Raise your hand, Dr. Maria.
Hello, do you hear me?
Yes.
Yes.
Congratulations.
Thank you so much for this opportunity. In this research, we have built a captcha method for blind and visually impaired people to help them use the internet and make the captcha method more accessible for this population. Thank you so much, Dr. Manar, and all organization committee. Thank you so much for this opportunity. Next year, inshallah, I will attend.
Thank you. Thank you. Thank you, Doctor.
You're welcome.
So now we move to our second category, and our first winning team, Wad Atiq and Professor Hind Al Khalifa.
Also from Saudi Arabia, from
Also-
King Saud
yes.
University, they took the 20,000. Please raise your hand so that we allow you to talk. We have a great female researcher from Saudi Arabia. We were very impressed. They submitted high number of submissions and applications to the third Forum for Women in Research. We are very proud of them. Their posters are outside if you are interested to see these posters. And are you?
Assalamu alaikum. Hello.
Congratulations. Go ahead.
Yeah, thank you very much. This is Professor Hind Al Khalifa with the Wad Al Atiq. First of all, I want to thank you for this great forum. It was a pleasure having me and my student selected as the first winners for the category. Our research is about using AI, machine learning and deep learning techniques to help researchers to select the best venue for publication in terms of, we know that there is a predatory publishers that newcomers to the area who want to publish, they don't recognize. So we developed a tool that helps them to select the best journal for whether it is predatory or not. And another thing to say, WID has already delivered a female yesterday. So she also sent her congratulations for winning this award. Thank you.
Thank you,
Prof.
Professor.
Muammar is interested to take your prototype to use it in the University of Sharjah. Will you offer it for free?
Definitely, definitely.
Thank you.
Thank you.
Okay, our second winner is Mariam Al-Dhabhi, a master student. Maria?
And Mariam from University of Sharjah, done her master's thesis with Dubai Police.
Assalamu alaikum. Millions of thanks for the organizer community, and especially for the my sweetheart, Dr. Manar, and congratulations for all of us. Thank you.
Congratulations, Maria. مبروك مريم. مبروك بالتوفيق إن شاء الله. And then we have Ala Harb and Professor Muhammad Ghazal from Abu Dhabi University. Congratulations.
Yes, it was my pleasure to participate with my research under the topic diverse distant student, deep emotion, recognition and visualization. And I would like to thank all of you for this great opportunity. Thank you so much.
Congratulations, Ala. Yeah. Be careful, that's the money. Don't lose it. Okay. So next we have Lama Shali and Dr. Muhammad Al-Shahri from the University of from Taif University, Saudi Arabia. I think they will be online.
Yes. Please raise your hand. Congratulations again from Saudi Arabia.
Hi, I am audible.
Yes,
we can hear you.
It was an honor to participate in such amazing forum. Thank you all for this an amazing event to empowering women. Basically, my research was about using AI techniques to empowering cybersecurity in the IoT network. Thank you all.
Thank you, Lama.
Congratulations.
Thank you. بالتوفيق.
Thank you.
Next, we have Li Fan Yu and Dr. Yi Fang from New York University, Abu Dhabi.
She was the first one who came to the forum today at 8 a.m.
Please give her another round of applause. Just for coming from Abu Dhabi, I guess, right?
Yes.
Please.
I'm very honored to participate in this forum, and thanks to all the organizers and all the sponsors and all the winners here. We're all winners, and my research is about, it's called CV4LV, computer vision for low vision. So we introduced a software system with a simulation environment for this wearable assistive device for people with visual disabilities. We used computer vision models with a deep reinforcement learning machine that will help the user make safe decisions and action planning in their daily lives.
Impressive.
Thank you.
Thank you, Lipa. Thank you. Congratulations. I'll take this. So next we have Ms. Ghada Al-Hussein, Muhammad Al-Khadri, and Professor Leontios from Khalifa University.
Thank you very much. It's an honor to represent Khalifa University in such a prestigious event. Thank you very much for the opportunity.
Thank you.
Everybody's shy.
Congratulations. Don't forget your hat. Okay, so next, Amal Ali, Dr. Muhammad Al-Sayyah, Dr. Amani Al-Othman, Hassan Al-Nashnash from the American University of Sharjah. They're coming?
Yes. They are our neighbors.
Yeah.
Neighbors and competitors. And collaborators.
Thank you so much. Assalamu alaikum, everyone. It is such a pleasure to be here to participate in this really well-organized event. So thank you so much again. Our project is about the development of flexible electrodes to measure neural activity. Thank you.
Thank you. Congratulations, Aman.
تحياتنا للماستر student, I think he is. Yeah. No problem.
Thank you. Congratulations. From Khalifa University, Samar Abdul Wadud and Professor George Kara-Nicolos.
Samar, are you online?
Yes. Are you online, Samar?
Can you raise your hand so that you can mention?
Hello.
Yes.
Yes, we can hear you,
Congratulations, Samar.
Thank you, Dr. Manar. Many thanks for this special honor. I'm so glad, I'm so grateful to receive this appreciation from your side for my work and my efforts. My research project is almost about preparing or designing a hybrid material for atmospheric water generation, or in other words, to collect the water from the air. So hopefully, in the end, me and other researchers can reach to the stage we can say that we have air as a sustainable resource for water. So thank you so much. I'm so grateful, and I hope next year, inshallah, I will join you physically. Thank you so much.
Thank you, Samar. Congratulations.
Thank you.
Thanks so much.
Thank you, Samar. And next, from Khalifa University also, Sumaya Taher, Dr. Rashid Abu-Rob, and Dr. Ken Layo. Sumaya, are you with us online?
3 in rows from Khalifa University. We are so proud of you.
Yes, congratulations. Are you with us? Yeah. Oh,
coming all the way from Abu Dhabi.
I've done all the way.
Women travel, so no matter.
Because I am graduated from this university. Yeah, from renewable energy. Yeah. Thank you a lot. I would like to thank everyone for organizing this event. This is my first time to participate, but inshallah not the last time. Sure, for sure. Thanks a lot.
Mabruk. Congratulations, Sumaya. From the University of Sharjah, Safira Sadaq, Professor Abdullah Shnabla, and Dr. Thuraya Bachharji. Sorry.
Assalamu alaikum to all. I would like to thank you, the organization team, and it's great honor for me to receiving this award. And thank you all. And my work is related to magnetic nanoparticle encapsulated in polymeric alginate beads. As for the removal of phosphorus from the wastewater. Thank you.
Congratulations. So now we move to our third category. Good. So Ms. Rida Al-Muhiri, Professor Fawzia Jabin, and Aisha Saif Al-Ali from Abu Dhabi University.
Assalamu alaikum, everyone. How are you all doing today?
Good.
Well, first of all, thank you very much to the organizing team for giving us an opportunity to showcase our research. This is not going to motivate the faculty, female faculty, but the female researchers, especially the master's students, the doctoral students, and even the undergraduate students to kickstart some research initiatives in the near future. And they know that people are there to acknowledge, like University of Sharjah. Now, again, I would like to thank the organizing team, Dr. Manar, and the whole organizing team. Even Dr. Manar has replied my email at 2 a.m. in the night. Can you imagine? Sir, okay. I was thinking she is having a sleepless nights like me doing research. So, but anyways, thank you very much for all your efforts. My research was, or our research was, by the way, just to let you know that this research is an outcome of a coursework, dissertation coursework at Abu Dhabi University, and the whole research was done in 6 weeks' time. So you can imagine that you can write a good research paper in 6 weeks if you are research focused, you have the hard work, and you have the perseverance to achieve that. Okay. Now in this,
I will have to stop you over here. Say one sentence.
Come on. Okay.
but I promise I'll give you time after.
Thank you.
I
Thank
have
you
my
very much.
reason.
Okay, just 1 minute. So this study is about, we studied about the employees' presentism, individual health, and its impact on their individual performance with the moderating role or moderating effects of supervisory support and spirituality at work. These are some of the novel dimensions that we have added. The data was collected from public sector organizations in the UAE, and the study is going to give practical recommendations and insights to the policy makers in the public sector to improve their spirituality at work, to improve the supervisory support, and to improve the individual health, basically, which is very important after COVID. So thank you very much, and thank you for giving me the opportunity again.
Thank you, Dr. Fawzia, for this energetic word. Thank you. And please, for all the winners, stay with us, okay? We will have a group photo at the end. Congratulations to your team, Prof. Fawzia. So next we have Alia Al-Ali from Abu Dhabi University also. Alia, are you with us? Yes.
Assalamu alaikum. Thank you so much. I'm delighted to be over here participating in such a great initiative or event. And if speaking about my research, it's basically focused on 3 main core components, which are sustainable leadership, and then ethics and sustainability. I would leave the time for the others to read my poster outside and know more, and perhaps connect with me to know more about the research. Thank you once again.
Thank you, Alia. And from the High College of Technology, please welcome Dr. Rihab Parsa and Dr. Juan Zamfri.
Thank you very much for this opportunity. Congratulations to all the women here, women researchers. So our research is about the effect of COVID-19 or corporate gender diversity, how COVID-19 affected employment and gender diversity. It's a global perspective.
Thank you. Next, we have Fatma Salim and Dr. Ahmed Raza Bilal from Oman, from Sohar University. I think they are online. Fatma Salim, can you please raise your hand?
We received many submissions from Oman as well, like Saudi Arabia. We also received submissions from Kuwait and Bahrain, but the winners were from Saudi Arabia and Oman.
Yeah.
So Fatima, are you there?
Dr. Ahmed Raza Bilal.
Okay.
Okay, so we move to the next. Dr. Naima Binkari and Wad Al-Arimi from Sultan Qaboos University, Oman. Are you with us? Wad Al-Arimi?
Hello, can you hear me?
Yes.
Yes, I'd like to thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.
Alaikum salam.
Okay, so I'm being heard. Thank you very much for this opportunity. This is Dr. Naima from Sultan Qaboos University. I thank Sharjah University and the organizing committee for this forum and the energetic Dr. Manar for being so much in an outreach position to motivate us to submit. Our research was about the assessment of level of livability in commercial streets in the Gulf region with a specific application on the commercial streets in Muscat, Sultanate of Oman. We developed a mixed-use methodology to be able to give the opportunity to the specialists and decision makers to evaluate the levels of livability in our commercial streets. And I think this aspect is tremendously important to create or to regenerate life in our streets, especially commercial streets after COVID pandemic, and also in order to allow a healthy outdoors living in our cities. Thank you very much.
Thank you, Dr. Nama, and we hope to see you next year face to face over here. So
definitely.
Our last team in category 3, also from Sultan Qaboos University, Oman. So Dr. Benha Saburi and Noor al-Huda al-Hatali. Dr. Saburi? Are you with us? Yes, I think. Oh.
Hello, can you hear me?
Please, we can hear you. Please go ahead.
Hello, everyone. And I would like to thank University of Sharjah for organizing such an amazing event. And I'm very honored and thankful for being shortlisted and awarded. My representative, Noor, my student, is there. And just in one sentence, our research, for the first time, we measured the agricultural product diversification, and we estimated its effects on food security and water security, the two important things for this region, for GCC countries. Thank you again. And the floor is for my student and the rest. Thank you so much.
Congratulations. And I am really proud of you because you're empowering your master students, female empowering female.
Most welcome. Thank you so much.
Thank you. Congratulations, Noor. So that was our last team in category 3, but we are not yet done. We have a special prize. We reserved it to a special lady. You saw her on the stage. She was so energetic, and you will understand why you decided to give her this prize. So I would like to call again Professor Fawzia Jabin to the stage.
Professor Fawzia, she submitted 18 applications to this forum.
So 18 application was submitted thanks to her leadership. And you know what? I just met her before. This is the first time that she drive from Abu Dhabi by herself to over here. So we need to applaud her just for that. So now you can take all the time you need, Fawzia. Another round of applause, please, for Fawzia. She deserves it.
Oh, is it? Okay. I told you. Oh, thank you. Thank you so much. I'm speechless, although I talk too much. And
this is why I left you to the end.
Thank you. I didn't expect that I will be getting such a special treatment here in the University of Sharjah, especially in this forum. I'm a big proponent of female empowerment, and you can prove your worth through your knowledge and through your research acumen. People will acknowledge your efforts when you will do something good about the society and about the community as well. So I started doing serious research a decade before or back. And I realized Professor Dima is, by the way, my mentor and role model. Although I have met her in 2011 in the Academy of Management, and she was the chair of my session, and I was a very, you can say, nascent researcher at that time. And she was chairing the session, and I was looking at her in awe that I want to be like her. And then we lost the touch, and she was doing wonderful in her field and everything. And looking at her progress, that motivated. By the way, if you want to get empowered, you don't have to meet with your role model or mentor. You should just follow what they are doing, learn the virtual lessons, or you can say insights, what they have done, and you can take the ideas, embrace the ideas from them. And coming back to Prof. Dima's role, she came here, then we met before, and I came through the LinkedIn about this research in forum information. And it was a wonderful opportunity to showcase the research work of not only my research work, but my students' research work. We have a very good, successful DBA program at Abu Dhabi University. And in 6 weeks' time, we have developed a lot of research from those research coursework. So once again, thank you very much for giving me this treatment. And I wish you good luck. And the only thing I would like to tell you is never, 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 never give up. Okay? You will do wonders.
Before you leave, please come to the stage, everyone.
Yes,
Please,
yes.
everyone, the organizers and the participants, and we will send you your shortlisted certificate for those who are in the auditorium and who are online. Please, everybody in the stage, don't be shy. Please,
please.
Let's make a big group photo.
While our winners are getting back to the stage, I would like to thank Prof. Muammar. Well, he was very patient today, and all of us know, the committee of the forum know how much supportive he is for all our efforts. So please, a round of applause, a big round of applause for the support, the endless support of Prof. Muammar to this forum.
Everyone, don't be sad.
Our winner,
please come.
Committee
Everyone.
member.
Everyone.
Dr. Manar said.
We are all winners. Please come, everybody. You won. You won. You are shortlisted, so you won. 210. 380. How are you? لا 210 أو 380 يعني أخذنا تقريبا يعني شلنا 30%. كيف الوضع الناس And there is catering, please. All the posters are outside. The recording will be shared with you, inshallah. كل شيء. خديها. شيليها وخديها.